All right, so we're going to look at section 4.2 for Algebra 1 notes. This is part of your guys' Chapter 5 section, but we're still going to do section 4.2 with all the Chapter 5 stuff, okay? All right, so we're going to do our warm-up first. It's telling us to generate ordered pairs for the function y equals x plus 3, given x is equal to the following numbers, -2, -1, 0, and 1 and 2. And then to graph the ordered pairs. I forgot to erase the graph. I want you guys to be able to plug in these values of x and solve for values of y. So for example, on this first one, if we have y equals x, we're going to use -2 for our first x plus 3. That will come out to 1. Then if we plug in our second number, y equals -1 plus 3, that will equal 2. Y equals 0 plus 3, that will come out to 3. Y equals 1 plus 3, that should be 4. And then y equals our last x value is 2 plus 3, and that will give us a y value of 5. So graphing them, they're already here for you, but for example, the first one, -2, +1, we start at the origin, we're going to move over 2 spaces to the left because it's negative, and then we're going to move up 1 space and put a dot there, and you'll see that. So just make sure you guys really understand that if we're moving just remember that we always list x comma y, and our x values are moving left and right, and our y values are moving up and down, okay? So we're going to look at identifying a function and finding the domain and range of relations and functions. Okay, so relationships can be represented by graphs and also by a set of ordered pairs called a relation. So when we have a set of ordered pairs, it's called a relation. For example, if you guys run track for track meets, for first place, you get 5 points. For second place, you'll get 3 points. For third place, you get 2 points. And for fourth place, you get 1 point. So the scoring system, we can write that as a relation, and it can be shown in ordered pairs. So like for first place, you get 5 points. For second place, you get 3 points. For third place, you get 2 points. And for fourth place, you get 1 point. So this is a group of ordered pairs, and it's also called a relation, okay? So now it's telling us to express the relation. This is how we write relation. We use these brackets, and then our ordered pairs and end brackets. And it wants us to express it as a table. So we're going to list out our ordered pairs with coordinating y values. So for example, I'm going to start with 2, and the coordinating y value is 3. For my second ordered pair, my x value is 4, and my coordinating y value is 7. And then for my last ordered pair, my x value is 6, and my coordinating y value is 8, okay? And then if we were going to graph these for this first one, 2, 3, we would move over 1, 2, and up 1, 2, 3. And that's why that first dot is there. For the second number, we move over 4, 1, 2, 3, 4, and then up 1, 2, 3, 4, 5, 6, 7. And that's why that dot's there. And the last one, we move all the way over to 6 and all the way up 8, and that's where our last point is. Okay, when we express relations, we can also express them with mapping them out. So it wants us to express the relation as a table and as a graph. And then here's the mapping diagram. So we already did the table and the graph on the last slide. The mapping version is when you list out your x values and what they coordinate in terms of y values, and we use arrows to point to what they go with. So for example, the x value 2 coordinates to the y value 3. The x value 4 coordinates with the y value 7. And the x value 6 coordinates with the y value 8. So again, when we use a mapping diagram, we use arrows pointing from the x values to the y values that they coordinate with. Okay, now we're going to talk about what a domain and a range is. So this is pretty easy. Once you guys just have it memorized, I think you'll be fine on this. The domain of a relation is just the set of the first coordinates. In other words, it's just all the x values, okay? So domains are just the x values, and then the range are just all your y values. So domain is x values, range is y values. And another way of that we call this is our domain or our x values are the independent variables. And then our range, like I said, is all the y values, and we call that our dependent variable or dependent variables. Okay, so in that one example with the track meet, the domains are just all the x values, and we write them in brackets. So we list them out 1, 2, 3, 4. We just list out the x values. And for the range, we just list out the y values, and we put them in brackets. Okay, if you have a repeating x or y, you do not have to write it twice. Okay. So now we're going to look at giving the domain and range when we have a graph given. So for example, this graph here, it's the graph of a line, and we've got a point at 1, 4 and a point over here at 5, 3. So the domain is the values of all our x values. So if we look, our x values are going all the way from here at 1 all the way over to 5. So our ranges, our domain is 1 through 5. Okay. So our range is our y value. So if you look, our y's go all the way from here up to here. This value right here is the y value of 3, and this value is 4. So they go from 3 to 4. And then when we write that like an inequality, our domain is all the values from 1 all the way up to 5. So x is everything from 1 to 5. And our y's are everything from 3 to 4. Okay, a function is a special type of relation that pairs each domain with exactly one range value. So when we have a function, there are no repeating x values, meaning I cannot have an x value that has two different y values, okay? So if I have like the point 3, 2, 4, 7, and then 3, 6, because I repeated my y value and it has two different, because I repeated my x value and it has two different y values, this is not a function. If every x value has its own y value, then it's okay, it is a function. But if it repeats, it's not a function. So we're given a relation here, and we want to decide if it's a function or not. So we're going to list out our domain and ranges first. So our domain is just all the x values. So 3, 5, 4. And I don't have to list this 3 again since it's already listed once, but that should be a big hint to you right there. Our range is all of my y values, so -2, -1, 0, and 1. Now we have to decide if this is a function. Well, the rule of a function says that I can't have a repeating x value. I can't have an x value that has more than one y value. And if you look here, I've got the x value of 3 twice, and it has two different y values. So because of that, it is not a function. All right, let's look at one other example. So this is giving a mapping diagram, and we need to come up with the domain and range. So again, you'll see how the arrows point to what y value it's listed. So if I have to list the ordered pairs here, I would list them as -4, 2, -8, 2, because the -8 is pointing to the 2, 4, 1, and 5, 1. Now my domain is all of my x values, x values, -4, -8, 4, and 5. And my range is all my y values. Well, there's only 2, and 1. Now let's check. Do any of my x's, do I have any repeating x's? Well, if you notice, I don't. I do have repeating y's, and that is okay for a function. You just can't have repeating x's, so this is a function, okay? All right, now let's look if we can find the domain and range from the graph. Okay, so we're given a graph, okay? And we've got this parallelogram here. And I want to know what's the domain and range. Well, our domain is everywhere that we have our x value. So we have an x all the way from here to here. And if this is our 0 point here in the middle, this x value over here is 1, 2, 3. This value over here is 1, 2, 3, 4, 5, -5. So our domain, we would write this as it's -5 all the way up to 3. So x is everything from -5 all the way up to 3. My range, if we look, it starts down here at -2 and it goes all the way up here to +1. So my range is everything from -2 all the way up to 1. Now, we need to check, do I have any points where I have a repeating x value, or I have an x value that has more than one y value? You guys might have heard this called the vertical line test, where if I take a vertical line and run it across the graph, if it hits more than 2 points, then it is not a function. You can just kind of look here and see. For example, if I drew a vertical line right here, at that x value, I have 2 different y values. And basically, everywhere I draw a line, I'm going to have 2 different y values for every x value, and that is not allowed with a function, so this is not a function. Okay? So again, the main things from this section is graphing, knowing what the domain and range is, and knowing how to map out. If I tell you to do a mapping diagram for a relation, and then telling if something is a function. So you might want to ask questions on that when you're doing your homework to really understand that. And that is all.